An arithmetic sequence is a sequence of numbers where to get from one term to the next term, you're going to either have to add or subtract a number. So in this case, in order to get from 1 to 2, I'm just going to add 1, right? And this is true for all the numbers here, right? I just have to add 1 to get from one term to the next term. Now, the thing about arithmetic sequences is that this number right over here, the number that you constantly have to add or the number that you constantly have to subtract to get from one term to the next, this is something known as the common difference. Well, another example. Let's say if I have a sequence like this. What would be the common difference? Well, to get from -1 to -3, in this case, I would actually have to subtract 2, right? To get from -3 to -5, I would subtract 2. So this right over here, the common difference would just be -2. Now, let's say if we have an arithmetic sequence. Actually, let me use this as an example. Let's say if this sequence, for example, goes on forever. All right, let's say this sequence goes on forever. And let's say if we're trying to find the 48th term of this sequence. So imagine if this sequence went on forever, and in this sequence right over here, we want to find out the 48th term. How do we do this? So just to give you guys some kind of context, right? The term that we start with, we denote this as a sub 1. It's the first term, right? Which is why we put this 1 here. A sub 2, this would be the second term. A sub 3, this would be the third term, and so on. So how can I find the 48th term? What is the value of the 48th term in my sequence? Well, luckily, first of all, if you're just to do this by hand, just to list all the numbers out, that's going to be pretty annoying, right? I don't want to list out 48 terms. So there's actually a formula. This is the formula right over here. A sub n, so this n right over here, think about it as like a variable, okay? It's sort of like a placeholder. So in order to find any sort of value in your arithmetic sequence, what you do is you take the first term and you add it to n minus 1. N represents the location of the term, and you multiply this by d, and d represents the common ratio. And you're going to multiply this by d, where d represents the common difference. So let's put this formula to use. So since we're trying to find a 48th term, right? In order to do this, what we're going to do is we're first going to add the first term. So first term is -1, -1 plus n minus 1. This n just represents the location of the term. So in this case, our term is located at 48, right? You can think about it as like spot 48, right? Our term is located at 48. So that's kind of what it means. This n right over here should match up the n of what you're kind of trying to find. So in this case, I'm trying to find a 48th term. So that means that I have to put 48 in here, subtract 1 from it, and then I multiply it by the common difference. In this case, my common difference, -2, right? In order to get from one term to the next, that's -2. So I'm going to multiply this whole thing by -2. So 48 minus 1, that's 47. 47, that's -94. 94 minus 1, that's going to be equal to -95. And that is our answer. All right, say that I have this sequence right over here. Try to find the 50th term of the sequence. Well, notice how, all right, so 3 over 2, right? 3 over 2, I can write this as 1.5. Maybe this will make things clear. 5 over 2, I can write this as 2.5. Notice how every term increases by 1/2, right? Every term increases by 1/2 or 0.5, right? Moving from one term to the next. So my common difference is going to be equal to 0.5. My first term is going to be equal to 1, right? That's the term we're starting with. And in this case, I'm trying to find the 50th term. Plugging all these values into my formula, I'm going to get a sub 50 is equal to a sub 1 plus n minus 1. So in this case, n is 50. 50 minus 1 minus multiplied by the common difference. So this is going to be 49 over 2 plus 1. This is just going to be equal to 51 over 2, or 25.5 as your answer. Let's say if we know that the 44th term is equal to 10, and let's say in our sequence the common difference is equal to 2. what's the first term of the sequence going to be? So given a term that's not the first term, what's the first term going to be? Well, notice how no matter what kind of n value we put in, so no matter what term we're trying to find, notice how in our formula, well, our first term always stays constant, right? It doesn't change. And we're going to use this to our advantage. So let's say if we plug in n is equal to 44 into our formula. So if n is equal to 44, we're going to get a sub 44, which we know is 10. So let's substitute that in. So a sub 44, which is equal to 10. This is going to be equal to the first term, which we don't know, right? We're trying to find out, plus 44 minus 1, right? Because we said we're trying to find a 44th term. So this is going to be 44 minus 1, right? Times our common difference, which is equal to 2. So now what we can do is we can just isolate a sub 1 and we can get the answer. So 44 minus 1 is equal to 43. 43 times 2 is equal to 86. So this whole thing right over here is 86. If I subtract 86 from both sides, I get a sub 1 is equal to negative 76. And that's our answer. So in order to do these types of problems, just pretend like you're trying to find the 44th term. All right, in order to find the first term, what you do is you pretend like you're trying to find the 44th term. So you're going to plug in a sub 44, you're going to plug in 44 for n, right? Because notice how when we plug in all of these values, well, we know the value of a sub 44, right? That's given to us. We know that we're on the 44th term, right? That's given to us. And we know our common difference, right? Which is stated right over here. That's also given to us. So if we know all these three values, well, then we can solve for a sub 1, right? If we know the value of these three variables, right? If we know the values of three of these variables, well, then all we have to do is just isolate a sub 1, and then we can get the answer. A sub 30 is equal to 60. And let's say my common difference is equal to negative 3. Find the first term. What's the first term going to be? Well, in order to find the first term, what I'm going to do is, okay, I'm going to say, imagine if I plug in n is equal to 60. What I'm going to do first is I'm going to say, okay, imagine if I plug in n is equal to 30 into my formula, right? Because we already know the value of the 30th term. So let's just substitute the 30th term into our formula, or n is equal to 30, right? So we're going to get a sub 30 is equal to a sub 1 times n minus 1 times the common difference, which is negative 3. We know a sub 30 is equal to 60. We know that we're on the 30th term. So instead of n, we're going to replace it with a 30. And now notice how all we're left with is a sub 1. And then, we just have to isolate the variable. So 30 minus 1 is 29. 29 times negative 3, that's negative 87. So if we add 87 to both sides to isolate the variable, add 87 on both sides to isolate the variable, we're going to get 147. And that's going to be our first term. Our first term is going to be 147. Now, let's say if we're given the 45th term of a sequence is equal to 30. Let's say if the common difference is equal to negative 2. And we're trying to find the second term. Wait, hold up. How the hell am I supposed to find out the second term? Right? How do you do this problem? Well, let me show y'all how to do this problem first. So in order to find a sub 2, we need to know what a sub 1 is equal to. Okay? Because once we know what a sub 1 is equal to, then look what happens. If we know what a sub 1 is equal to, well, I can plug in n is equal to 2 into this formula. So I get a sub 2 is equal to the first term, which we know, plus the term we're on, location of the term, which we also know, and then our common difference, which we also know. So then we will get an actual value. So in order to find out, right, let's say if we're given a term in a sequence that's not 1, all right, and we're trying to solve for a term that's also not 1 in this arithmetic sequence. Well, in order to do that, you have to find out what the first term is. This is going to be your first step, all right? You have to find out what the first term is first. So in this case, what I'm going to do is I'm going to plug in n is equal to 45 into my arithmetic sequence. So I'm going to get a sub 45 is going to be equal to a sub 1 plus n minus 1 times the common difference. Now, a sub 45, we know that's 30, right? We know the n value, well, that's 45, right? We're on the 45th term. And the common difference, -2. So we're going to have 45 minus 1, which is 44. 44 times -2 is -88. If we add 88 to both sides to isolate the variable, plus 88 to both sides, we're going to get our first term is going to be equal to 118. So that's going to be our first term. Okay? So let me just move away like this. Now that we know that the first term is equal to 118, well, now I can find a sub 2. Look at this. So a sub 2 is going to be equal to the first term, which we now know was 118 plus n, which is, in this case, n. We're on the second term, right? Imagine if we plug in n is equal to 2, right, into this tiny n right over here, right? So we're on the second term. So we're also going to have to plug in a 2 for this n. So it's going to be 2 minus n, n minus 1, or 2 minus 1 times the common difference, which is -2. This is equal to 1. 1 times -2 is -2. So this is going to be equal to, a sub 2 is going to be equal to 118 minus 2 is 116. And that's going to be our answer. So when you're doing problems like these, in order to find out a term that's not 1, given a term that's not 1, you have to find the first term first. Because look what happens. Imagine if I didn't know what the first term was. Imagine if I didn't know that a sub 1 was equal to 118. And I decided to plug in 2 into my formula, right? Then what I would get is a sub 2 is equal to a sub 1 plus 2 minus 1 times the common difference, which is -2. So imagine if I did not know what my first term was. Then how the hell am I supposed to solve this problem, right? So in order to find a sub 2, well, we need to know what a sub 1 is equal to. And, from the previous problems before, we learned how to solve for a sub 1. So this is very important. Solving for a sub 1 is very important because it allows us to get basically any term. If we're given our 25th term is equal to 70, common difference is equal to 3, and we're trying to find out the fourth term, feel free to pause the video to try this out yourself. Solving this in 3, 2, 1. Okay, let's go. Remember, always want to find out the first term. All right, so in this case, I'm going to plug in what we know. So n is equal to 25. Let's plug this in. So I'm going to get a sub 25 is equal to a sub 1 plus n minus 1 times the common difference. We know our 25th term is 70. We know our n value is 25. We know our common difference is equal to 3. 25 minus 1 is equal to 24. 24 times 3 is equal to 72. And if I subtract 72 from both sides to isolate a sub 1, I'm going to get that a sub 1 is equal to -2. Now that we know our first term, let's solve for our fourth term. So now I'm going to plug in n is equal to 4 into my formula to find out the fourth term. So I'm going to get a sub 4 is equal to the first term plus n minus 1. So in this case, 4 minus 1, right? Because we're on the fourth term, times the common difference. 3 times 3 is 9. Minus 2, that is 7. So we get a sub 4 is equal to 7. And that's going to be our answer. And you can confirm this, right? If we know our first term is -2, then look, our second term, so this is my first term. Let me just write this out. So if my first term is -2, well, my second term, if I add 3 to it, which is my common difference, I'm going to get 1. If I add 3 to this, I'm going to get 4. If I add 3 to this, I'm going to get 7. So everything makes sense.